In this lesson, we'll talk about polynomials and their zeros, and a characteristic of the zeros is multiplicity. So let's take a look at, here are some polynomials, and if we found the zeros, we would make the y equal to 0. And so when we solve this, the 0 is x equals 0. Here the 0 is x equals 0. Here the 0 is 1. And here it is negative 2. Because we would just do the cubed root of this. And then we have something called the multiplicity. Is the multiplicity refers to this exponent, so this is even. This multiplicity is odd, and this multiplicity is even and odd. And so that tells us what's happening to the graph at the x-axis. The behavior of the graph at this 0 is it's going to turn back. At this 0, because it has odd multiplicity, it's going to cross the x-axis. Even multiplicity, it is going to turn back, and at an odd multiplicity, it crosses the x-axis. We see that in a parabola. It turns back when it hits the x-axis. The cubic graph hits the x-axis and crosses it. Here at the x-intercept of 1, the graph turns back. So it's going down and then it turns back. At the x-intercept of negative 2, this graph is going to cross. And that's how multiplicity works. Let's also use the leading term from the last lesson. And in this problem, the leading term is going to be x squared times x was x cubed times x is x to the 4th. So if we look at the leading term, it's positive x to the 4th with some other terms. So we know positive means it goes up to the right, and 4 means even. Exponent means it goes the same direction on both sides. So it's going to go up to the right, it goes the same direction, so it's going up in both directions. So we know that's the end behavior due to the leading term. Let's find the zeros. Make the y 0 to find the zeros, and we get x equals 0, x equals 4, x equals negative 2. So set each of these equal to 0, and these are the zeros. You could also say the real zeros, and you could also say the x-intercepts. They all mean the same thing. Let's look at the multiplicity. Multiplicity of this 0 is even. The multiplicity of this 0 is odd. The multiplicity of this 0 is odd. And then we'll talk about what happens in the graph. Behavior. Even means it turns back. Odd, it crosses. Odd, it crosses. So then we can sketch it. 0, 4, and -2. And we know that it's going to positive infinity. That's the end behavior from the leading term. And then we just have to follow this and see what's going to happen at -2. It's going to cross at -2, so we know it goes down through. At 0, it's going to turn back. So that means it's going to come up like that. And then at 4, it crosses. So it'll go back down and come back up. And now we have more strategies of sketching graphs. Pause the video and try this one. Alright, so here it's going to go up to the right, but it goes in opposite directions. So we know it goes up to the right, but opposite directions. So there's the end behavior. And let's look at the zeros. Okay, and each of them equals 0. So divide by 2 and we get 0. Here we're going to do square root of both sides and then subtract 5. Square root both sides and add 3. So then we look at the multiplicity of 0. The multiplicity of this 0 is 1. Odd. The multiplicity of -5, the multiplicity is even. And the multiplicity of this is even. So we know that odd, cross, even, turn, even, turn. And we know it's going down this way and up that way. So at -5, it's turning. At 0, it crosses. And at 3, it turns. Okay, pause and try these this one you have to factor. So work on both of these and then check your work. Here it's going to go down to the right, and then this means it goes the same direction on both sides, even degree. We know it's going to look like that. So we could divide by negative and we'll still have a 0. Square root and we still have a 0. Negative 2. And do the same thing over here. We get 4. So we have zeros of negative 2, and we'll talk about the multiplicity of negative 2. It came from this factor, and this factor has an even multiplicity. This 0 came from this factor, and this factor has an even multiplicity. So we know it's going to turn at the x-axis, and we're at negative 2 and 4. So we know the graph is down on both sides, and it's going to turn at both x-intercepts. So it might look like that. Here the leading term is negative 2x cubed. So the negative means it goes down to the right, and the odd degree means it goes in opposite directions. Here we have a common factor. Now let's take out a negative 2x. We have to multiply to get negative 3, add to get 2, and this will give us the zeros. Now we'll set them equal to 0, 1, negative 3 divided by negative 2, and we get 0. And the multiplicity of this 0, it came from this factor with a degree, an odd degree. This negative 3 came from this factor with an odd degree. This 0 came from this factor with an odd degree. So then we know it crosses the x-axis at all of them. 0, 1, negative 3. At negative 3, it's going to cross. We have to look at the end behavior. It's going to go like that. So it crosses, crosses, crosses. So here's another type of question. associated with these concepts. So if we have a 0, then we subtract 2. Now we could say that's the factor, and it has to have degree 3. So we're just going to make something up that has degree 3, and it also has this 0. Here we have x equals 6 and x equals negative 3. Those are zeros. Subtract 6, add 3. So we have x minus 6, x plus 3, and we have to have degree 4, so we could put a 3 here and a 1 there, or a 1 and a 3, or a 2 and a 2. So there are many correct answers. Let's just say that. And then we also have the option of putting a coefficient out here, infinite possibilities out here, so there's infinite correct answers. Pause the video and try this one. And it's degree 5, so you can just spread the degree out among the factors, and if we just put a 1 there, a 2 and a 2, or you can mix them up any other way as long as the exponents add up to 5. Same thing here, and let's just review expanding it. So if x equals 4, we get x minus 4. If x equals negative 8, we'll add 8 to the other side, and we get a factor of x plus 8. Here we have a factor of x plus 2. So we could say we have that. And then we'll just multiply that. We have to distribute this, and then we'll distribute that. Negative 4 plus 8. And here's negative 32. And then to keep this organized, we can always organize it like this. This multiplies to get that. This multiplies to get that. Two times 4x, 2 times negative 32, and then we have x cubed. This will be 6x squared. That'll be negative 24x minus 64. So here's one polynomial with these zeros, but they're infinite polynomials because you could just put any coefficient out here and then you'll have a different polynomial. Okay. And we'll stop there.